Dear student, yesterday we talked about the electrochemical type of corrosion. Actually, we have seen the blueprint, how electrochemical type of corrosion proceed. And we have also seen there are two different types of mechanism to be followed in electrochemical type of corrosion. Depending on the nature of environment, if your environment is acidic, then evolution of hydrogen or release of hydrogen type mechanism will be followed to proceed further corrosion. But in case your environment is neutral or basic, then absorption of oxygen type mechanism will be followed. We have also discussed how your environment become acidic, basic or neutral. As I have told you earlier, wherever human being will live, they will make that environment acidic because of regular respiration, in addition to other activities like cooking, communication. In all these activities, acidic kind of oxide are released, which after being absorbed in moisture will release corresponding acid, making your environment acidic. And today we'll be discussing on the mechanism involved in evolution of hydrogen type. Let us see. Evolution of hydrogen type. This is an area where you have to construct an infrastructure. As I have told you earlier, in case of any infrastructure, we generally use iron. The reason was iron is cheap, abundant, but unfortunately it is very much sensitive towards corrosion. Because of that, we have to take precautions. One thing I would like to tell you, this job is actually for civil engineers. If we are honest to our responsibilities, the kind of building we are going to make, as we know that if our environment is acidic, we should take due precautions before making the infrastructure. Some kind of measures we should take so that in the long run corrosion does not take place. But the problem is that if we want to do some kind of precautions we should take some kind of measures in this regard, the money involved will be used. Because of that, many people, in fact, particularly in India, try to avoid this step. Because of that, within a very short span of time, building collapses, bridge breakdowns, and sometimes building also collapses. So we will be talking how this thing happens one by one. And suppose this is an area where we have to make an infrastructure. Suppose this is the infrastructure we have made. As we know that iron will be the metal being used here for the infrastructure. Iron being a metal, we know it will have a general tendency to give up electron. We also know that loss of electron is oxidation, and this thing happens in anode. In our previous lecture, we have seen in an electrochemical cell, two electrodes will be used. One of them will have higher position in electrochemical series and will behave anodic, and second one will be cathodic. So as if this is the metallic structure, it will be made of n number of metallic layer, and we have seen earlier metallic atom on the surface of the metal will have a tendency to give up electron, and therefore entire metallic surface will become your anode. And one thing I have forgotten to tell you, your environment is acidic. This is very important. So, since your environment is acidic, there will be a lot of H+ ion in the environment. This will be the situation. Now, the entire metallic structure surface has become your anode. There is no cathode as such. There are two different situations. I shall discuss one by one. Assuming that there is no impurities on the metallic structure, what will happen? Iron will give up 2 electrons to produce Fe2+, oxidation. Now the electron being released here due to oxidation, due to anodic reaction in fact, they will move here to there on the surface. Being acidic in nature, H+ ion will be there on all along. Suppose this is the point where this electron meets a proton, that is hydrogen ion. Automatically this particular point will become your cathode. And what will happen? This H+ ion will gain this electron to produce H. After some time, two such H will combine together to produce molecular hydrogen. Hydrogen being a gas, it is now being released. And that is why it is known as evolution of hydrogen or release of hydrogen. But most important thing, what I would like to tell you, there are 5 important points you have to keep in your mind while discussing this mechanism. Number 1, your environment is acidic. It is very, very, very important. Without writing this, you cannot show the diagram like that. Then identification of your anode, identification of your cathode, then it is anodic reaction, this is your cathodic reaction, and then evolution of hydrogen. These are 5 different steps involved in it. Number 1, I repeat, the nature of your environment, it will be represented at the top. Then identification of your anode, followed by cathode, anodic reaction, cathodic reaction, and release of hydrogen. This is one situation. Now assuming that, we know that in any metallic structure there is every possibility some kind of impurities may be there. Suppose some kind of impurities like copper is there. So since it is a metallic structure made of basically iron, but some kind of impurities like copper is there, iron stands higher than copper in electrochemical series, automatically iron will become your anode. The entire metallic surface will become your anode, and copper, where copper is present, it will become your cathode. At anode, loss of electron will take place, as we have discussed earlier. At cathode, hydrogen H+ ion will gain 1 electron. After that, 2 such hydrogen atoms will combine together to produce molecular hydrogen. Being a gas, it is now being released. This is how actually corrosion proceeds in 2 different ways, 2 different situations here in evolution of hydrogen type mechanism. There are some important features which I would like to tell you, which are very, very important for you also. Around 4 different features, important features to be discussed here. Number 1, if you look at here, your entire metallic surface will becoming your anode, and cathode will be either a spot where H+ ion will get in touch with the electron, or the impurity like copper is present. And therefore we can tell that here anodic area will be very large and cathodic area will be very small. Number 1. Number 2, there may be more than 1 cathodic area. You have seen it. The point at which H+ ion will meet an electron, or copper or any other impurity is present on the metallic surface, that particular point will become your cathode. And therefore, if there are 10 different areas where proton is actually accepting the electron, there will be 10 cathodic area. That means there may be more than 1 cathodic area. Number 3, if you carefully observe, you will see that at anode, loss of electron takes place. It means electrons are being supplied by anodes. Anodic area being very large, supply of electron will be excessive. But cathodic area being very small, where absorption of electron will take place, therefore rate of corrosion will be very, very low. And number 4, anodic area being very large. And we also know that corrosion takes place only at anode. This may take place, corrosion may take place here, anywhere on the metallic surface. The exact location where corrosion will take place we do not know, because the entire metallic surface will be susceptible to corrosion, as the entire metallic surface is your anode, because we know anode corrosion takes place at anode. And therefore, since the exact location where corrosion will take place is not known to us, and therefore this mechanism is also known as delocalized type of corrosion. Delocalized, the exact locality where corrosion will take place is not known to us, and therefore this is also known as delocalized type of corrosion. This is all about your mechanism involved in evolution of hydrogen type. I would like to remind you, diagram is very, very important. Writing the important aspect, that is the environment is acidic, identification of anode, identification of cathode, anodic reaction, cathodic reaction, and evaluation of hydrogen. These are very, very important. This is your anodic reaction, this is your cathodic reaction, this is your actually overall evolution of hydrogen. These are very important, and after that you have to mention all the 4 important features I have told you. Those points are: number 1, anodic area is very large, cathodic area is very small, and number 2 was, since cathodic area becomes the point where proton will come in touch with the electron or the impurity. If there are 10 different places on the metallic surface where a proton is meeting electron or impurities are there, there will be 10 cathodic area, and therefore in this case there may be more than 1 cathodic area. And number 3 was, anodic area being very large, supply of electron will be excessive, cathodic area being very small where consumption of electron will take place, rate of corrosion will be slow. And number 4 was, anodic area being very large, and exact location of where corrosion will take place being unknown to us, and that is why it is also known as delocalized type of corrosion. This is all about your mechanism involved in evolution of hydrogen type corrosion. I firmly believe you might have understood. Please go through the video very carefully. If there is any doubt, note it down. During our conversation and discussion, you please clarify your doubts. Thank you very much.